Good morning, students. Now we are going to talk about another new engineering material which is called shape memory alloy. So there is a definition in its name itself. Depends on the shape of an alloy that memory will be stored. That is, those kind of alloys have a different shapes depends on its temperature. The temperature will be stored in that alloy in the shapes, in their shapes. So those materials are called shape memory alloy. So we are going to talk about now what is shape memory alloy. So there is a two stable phases in this alloy. One is called austenite phase, which is a high temperature phase, and another one is martensite phase, which is a low temperature phase. The high temperature austenite phase is a hot phase, but the martensite phase is a low temperature phase in soft in nature. So the martensite, it can be deformed because of its soft nature. It can able to deform into twinned martensite shape or deformed martensite shape. That phase transformation can be occurs between these two phases depends on heating or cooling. So these are the structures of the austenite and martensite shape. The austenite is a high temperature phase. We said it is a very hard in nature. So whatever the stress is applied, it cannot able to deform. Whereas the martensite is a very soft in nature. By applying a load or stress on it, it can easily deform. And we can able to prepare this metallic shape memory alloys by so many methods. One of the method is a vacuum induction tube method, and it is not in our syllabus. Now we directly go into the properties of the shape memory alloy, and the first property is shape memory F8. So there is a graph here between the temperature and load. So the graph will says that at higher temperature we have only the austenite shape is a regular arrangements of an atom in a crystalline format. Whereas when you reduce the temperature of it, it become a twinned martensite. The twinned martensite is the same kind of an alloy, but the shape will be different. It is a very soft in nature, so it is a twinned shape. And on twinned martensite shape, if you apply the load on it, it becomes deformed into deformed martensite. And on the deformed martensite structure, when we again heat that, it again convert into a austenite shape. So this is called a shape memory effect. That means the temperature will be stored in a particular shape of the alloy. And this is the second character. This is called hysteresis, shape memory hysteresis, which means the conversion of temperature from conversion of the alloy from martensite into austenite, or else austenite into martensite, not in the same temperature. So this graph says that it's a temperature versus martensite shape. So martensite shape and x-axis is temperature, and our higher temperature, it is a perfectly a austenite shape. It's perfectly a austenite shape, and when you reduce the temperature gradually, and at ms temperature the material will start into martensite, and at mf temperature it is completely become a martensite. So at lower temperature, all the lower temperature, it's perfectly a martensite shape. The mf stands for martensite starting temperature, and mf is martensite final temperature. Similarly, when you raise the temperature of an alloy, again the martensite will start to convert into austenite, but the conversion is not occur in the same rate. It will be converted into some other higher temperature. See, at as temperature the austenite will start, at af temperature the austenite will be completed. So this graph, temperature range between this conversion, which is called hysteresis temperature. And the next property of the shape memory alloy is pseudo-elasticity. Pseudo-elasticity means it's the elastic behavior of the shape memory alloy. Still now we discussed that temperature will play the major role for conversion of the shapes of the alloy. Now this is a peculiar property of an alloy. Without changing the temperature, just by applying the stress on a material, we can able to get shape changes. That is called pseudo-elasticity. So this graph will say that the stress and strain graph, in which there is a portion called A, B, C, D, where AB is a high stress and CD is a lower stress. And AB portion, the material behaves like a oscillate shape, whereas when you reduce the stress of the material, it will behave like a martingale shape. So by only changing the stress of a material, we can able to change the shapes from martensite to austenite or austenite to martensite. So this is called a pseudo elasticity. That means without changing the temperature, by only changing the stress, that material shapes can able to change. That's called pseudo elasticity. Then now we come to the topic about application of shape memory alloy. And this is one of the application called shape memory valve. So here there is a fine strip will be here, that is called shape memory alloy diaphragm. So the diaphragm is a very thin diaphragm, and depends on the temperature of the diaphragm it can able to change the shapes. So first, on the first diagram, it is a modified shape. That means it is in the lower temperature a deformed shapes, so that at the time the valve will be completely closed. The check valves are closed. Whereas if you apply the current through the wire, that deformed diaphragm wire, SMA diaphragm wire, and the temperature will increases. When the temperature is increases, it becomes straight. When it is straight, the valve will get open. So it just depends on the current to it, that is depends on the temperature of the diaphragm. It can be changed from one shape into another shape, so that it can act as a valve. Then the biological applications of shape memory alloy. So first, it can act as a bone plates. So depends on the stresses we apply, it can able to change the shape so that it cannot affect the body. And surgical anchors and teeth tighter and sunglasses, in all these cases we can use this shape memory alloy, especially in a sunglasses. If the temperature is fall on the sunglasses, it can act as a it is act as some different colors. It is behaves like a different colors. Okay, sunglasses. Thank you.